स्टार्ट करते हैं बेटा विद द कार्बोक्सिलिक एसिड्स। तो कार्बोक्सिलिक एसिड में आईयूपीएसी नोमेनक्लेचर हम नहीं कवर करेंगे। वी विल डू आईयूपीएसी नोमेनक्लेचर, जैसे जैसे कंपाउंड्स बनेंगे वैसे वैसे क्या करेंगे, वी विल अंडरस्टैंड कि उनका नोमेनक्लेचर कैसे करना है। तो वी विल स्टार्ट विद जनरल मेथड ऑफ प्रिपरेशन ऑफ कार्बोक्सिलिक एसिड। तो उसमें जो सबसे पहला मेथड ऑफ प्रिपरेशन है वो क्या है बेटा, फ्रॉम दी प्राइमरी अल्कोहल्स एंड एल्डिहाइड। प्राइमरी अल्कोहल्स और प्राइमरी एल्डिहाइड्स का मतलब क्या है, जिसमें कार्बन की डिग्री कितनी होगी बेटा, कार्बन की डिग्री होगी 1, ठीक है। सेकेंडरी टर्शरी अल्कोहल्स एल्डिहाइड्स नहीं लेंगे। कैसे होगी, देखो फॉर एग्जांपल आप कोई भी ले लो, लेट्स टेक प्राइमरी अल्कोहल लाइक दिस RCH2OH। तो उसमें क्या होगा, RCH2OH लिया तो आप क्या करोगे बेटा, क्या कराना चाहिए, देखो ऑक्सीडेशन कराएंगे, ठीक है। ऑक्सीडेशन कराएंगे इन द प्रेजेंस ऑफ फेमस ऑक्सीडाइजिंग K2Cr2O7, K2Cr2O7, या फिर आप प्लस KMnO4 ले सकते हो, पोटेशियम परमैंगनेट, ठीक है। और पहली बार जब ऑक्सीडेशन होगा, फर्स्ट स्टेप में जब ऑक्सीडेशन होगा तो आपको क्या मिलेगा, एल्डिहाइड। अल्कोहल का, प्राइमरी अल्कोहल का ऑक्सीडेशन करोगे तो क्या मिलेगा बेटा, यू विल गेट एल्डिहाइड। एल्डिहाइड, अंडरस्टूड, यस, ठीक है। एक बार और ऑक्सीडेशन करोगे तो व्हाट यू विल गेट, अगेन यूज द सेम ऑक्सीडाइजिंग एजेंट्स K2Cr2O7 plus KMnO4, potassium permanganate, what you will get, RCOH, carboxylic acid, understood? Yes. We can help this with a simple example by taking ethanol. I have taken ethanol. ethanol का क्या कराएंगे, ऑक्सीडेशन, ठीक है। ऑक्सीडाइजिंग एजेंट्स यहाँ पे यूज कर लेंगे KMnO4 plus K2Cr2O7, ठीक है। ऑक्सीडेशन कराया बेटा, ये सब क्या है, स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट्स, ठीक है। क्या होगा, पहली बार जब ऑक्सीडेशन कराएंगे तो आई विल गेट इथेनॉल। व्हाट आई विल गेट बेटा, आई विल गेट इथेनॉल। नाउ इथेनॉल का फिर से ऑक्सीडेशन कराएंगे सेम ऑक्सीडाइजिंग एजेंट के साथ में, सो व्हाट आई विल गेट, आई विल गेट एसिटिक एसिड, CH3COH, अंडरस्टूड। एसिटिक एसिड कॉमन नेम है कार्बोक्सिलिक एसिड का, एसिटिक एसिड। आईयूपीएसी नेम क्या होगा, 1 2 मेथड मेथेनोइक एसिड, sorry ethanoic acid, correct, 2 carbon atoms are there, method, so this will be ethanoic acid, ethane and oic acid, ethanoic acid, understood? Yes. So this was the simple method from which we can prepare alcohol. एक example हो गया, and let's take one example of aromatic alcohol in this way. Let's suppose this was our alcohol CH2OH, right? And now you want to do the oxidation KMnO4 plus K2Cr2O7, understood? So what I'll get beta, I'll get benzaldehyde CHO, correct or not? Benzaldehyde, have you seen this compound, benzaldehyde? Yes, sir. And then further, if you further do the oxidation by using same this agents, no need to write once again. So this will be what, this will become benzoic acid. Which kind of acid this is? This is carboxylic acid, aromatic carboxylic acid. This is what, benzoic acid, understood? Understood? Yes, sir. And also, if you remember, I have taught you this thing. If you will use this thing, if you will take any aldehyde, right, and if you will add a tolerance reagent. So if you will add a tolerance reagent, what will happen? Tolerance reagent was what? You get a silver mirror, right? You have studied silver mirror test. So there will be deposition of pure silver, that is Ag, right? Pure silver on the test tube, then you will get a silver mirror. So why you get the silver mirror? Because of the formation of this deposition of this silver and formation of this acidic formation of acid. So how you will get this? You will get CH3COH, right, when you use this tolerance reagent. I'm not writing the complete reaction because we have already studied this reaction in aldehyde chapter, right? So this, I have written this only to explain you the oxidation part, right? So in a similar way, this is what beta, this is benzaldehyde, correct or not? Correct. So if you'll add Tollens reagent in a benzaldehyde, you will get what? C6H5 COH, benzoic acid. Understood?
सर इसमें एक ही स्टेप में वो कार्बोक्सिलिक एसिड फॉर्म हो गया ना?
Correct. Beta देखो, when you will do the oxidation, which part will get oxidized? This carbonyl group will get oxidized to form COH. Understood?
बट पहले भी तो एक ही स्टेप में था एल्डिहाइड से कार्बोक्सिल.
Correct, beta. Like this oxidation and reduction steps are only one step reaction process until unless you are using special kind of reaction, that is like we have studied in Clemmensen reduction reaction. So what happens in that? Directly from this aldehydes we get alcohols.
Yes, sir.
Correct or not? In Clemmensen reduction reaction. So this is only one step reaction. So that is why this is very easy, right? So now, like so far we have studied about this from alcohols. Now let us understand with the preparation of by use of nitriles. Okay, so let us understand what are nitriles. Nitriles are nothing but compound containing this bond, C triple bond N. So sometimes we also call this as cyanide.
Yes, sir.
And in general we call them as a nitrile, right? So if you take a compound like this, let's suppose in general I am taking this compound. So what is the name of this compound? So 1, 2, this is main functional group, this is additional group, this is methyl, so what method? So ethane nitrile, this is ethane nitrile. So what you will do with ethane nitrile? You will add water molecule to this compound, right, in the presence of acidic environment, or you can further use this reaction in the basic environment. Then what you will get? There will be, what will happen? This is beta, this is, if you are adding water, this reaction is what? This reaction is hydrolysis. Hydrolysis of nitriles. Hydrolysis of nitriles. So what will happen in hydrolysis? There will be addition of water molecule. So water molecule will be added. And you will get what? Carboxylic acid plus this NH will combine to form ammonia, and this gas will liberate. Ammonia gas will liberate and you will get acid. Understood?
Yes.
So in general, like I have written in general RCOH, but in this case if you have taken ethane nitrile, you will get an acid having same number of carbon atom. Means you will get CH3 COH. Means from ethane nitrile you will get ethanoic acid. Meth, ethanoic acid. Understood?
Yes.
Easy?
Yes, sir.
Okay, so let's take a aromatic compound of nitrile. Let's take benzene nitrile, or sometimes we call it as benzonitrile. More accurately, this is known as benzonitrile. Benzonitrile. So what will happen? Again, what you will do? You will do the hydrolysis part. So benzonitrile upon hydrolysis will give what? This will give what, beta? This will give benzoic acid plus formation of ammonia. Ammonia gas will liberate. This is what? Benzoic acid. Ammonia gas will get liberated. Understood? Easy?
Yes, sir.
Okay. Good. Now, let us, do you know how this benzonitrile is prepared? Benzonitrile, for your understanding, I am just telling you, this benzonitrile is prepared from what? This is prepared from aniline. And aniline look like this. You have already studied about this aniline. Have you seen this kind of compound previously? Aniline.
Yes.
So how we will get this? How we will get? What will happen? We will use this compound HCl. So this is kind of halogenation process, addition of halogen. and then you'll use this alcoholic KCN. If you remember this reaction, you'll use this alcoholic KCN, you'll get this thing, benzonitrile, right? This is not important as far as your this carboxylic acid chapter is concerned, but if you are studying this amines, then this reaction is very important. Important reaction. We will see this reaction once again when we study amines, right? Understood? Understood?
Yes, sir.
This is, see what is happening here. You know, there is, you know, a hydrogen atom is there, and this halogen is getting added. So what will happen? There will be loss of HCl. Halogen will get added to this. We'll get this kind of compound, and then again we'll use this alcoholic KCN. We'll get this nitrile, right? Understood?
Yes, sir.
Now let us understand. Ester कैसे दिखता है? What do you mean by esters?
R double R O R.
R C O R dash. This is general structure of ester. So what will happen when you use this ester, and upon hydrolysis, what will happen? Upon hydrolysis in acidic environment, upon hydrolysis we'll get what? See what will happen? This group will break from here, right? So we'll get carboxylic acid plus we'll get C. This from here we'll get what? We'll get ROH, alcohol. So what we have got upon the hydrolysis of esters? We have got carboxylic acid plus alcohol. Understood?
Yes.
So let us understand this with a very simple example. Let us take an ester molecule. Let us take ethyl acetate. Simple molecule. So let us take this ethyl acetate. Ethyl acetate. So what will happen? Just write here ethyl acetate. So what will happen? You do the hydrolysis of this part. What will happen in the acidic medium? From here, you know, this bond will break and water molecule will get added, right? OH will get added. So we'll get CH3. We'll get ethanoic acid plus we'll get ethanol. Easy. This is what? This is ethanoic acid. And this is what? This is ethanol. Understood? Understood, beta?
Yes, sir.
And do you know, like, what is this process called? Hydrolysis of esters. There is a special name to this process. The special name of this process is saponification. What is saponification? Saponification. Saponification.
सर आपने एग्जाम्पल गलत नहीं लिया
Why?
सर ethyl acetate is not an ester.
See, what is missing here? See, this is ethyl acetate, no? So, name is correct, but I have forgot to add this oxygen bond here. Now, this is ester.
Okay.
See, this is the general formula of ester. So, I forgot to add this single bond O in the compound. So, this is a ester only, right? So, the name of this ester is ethyl acetate. Or, you know, like, what is the IUPAC name of this compound? How you do the IUPAC name? See, you see this group. This is ethyl. This is methyl. So in a yes, I'm telling you. So in a alphabetical order, M come first or E come first? E come first. So this will be ethyl. Ethyl. Then meth eth. And oxygen bond is here. So this will be ethyl ethanoate. This is the IUPAC name of this compound. Ethyl ethanoate. Understood? Can we move to next step?
Yes, sir.
This is easy. This process is known as saponification, right? Please keep this in your mind. Understood? See, the general formula of Grignard reagent is RMgx. We already know. Grignard reagent is what? RMgx. So when we'll take this RMgx Grignard reagent and when we'll add a carbon dioxide molecule to this in the presence of dry ether, so what will happen? There will be a formation of additional product. So what is that addition product? Let's understand what will be the addition product. The addition product will be nothing but this CO2 will get added beta. CO2, this whole molecule will get added to this RMgx. How? See, this C is here, double bond is here, O is here, right? And you will get this kind of compound, RMgx. So this is an addition product, addition compound. Why this is addition product? Why we call it as an addition product? Because in RMgx, complete CO2 molecule gets added. Because addition is happening, that is why this product is known as addition product. Understood? Now, when you do the hydrolysis in acidic medium, what will happen? Upon hydrolysis, you will get what beta? As usual, you will get what? You will get acid, carboxylic acid. Plus, what you will get? This compound. You will get compound like this. Understood? Easy. From Grignard reagent. Let us understand this with a simple example. Let's suppose I am taking this methyl magnesium halide kind of compound. So I am taking bromide. So this is what? Methyl magnesium bromide. Methyl magnesium bromide. Understood? I am not writing the name. This is all already understood. Alright, beta. So let's take CO2 molecule, carbon dioxide molecule. How this CO2 look like? This looks like this. CO2 molecule. CO2. Understood? Now, in the presence of dry ether, what will happen? There will be addition of this complete CO2 molecule to this molecule. So let us add this, right? MgBr. So what will happen beta now? Now upon hydrolysis, HOH, this is hydrolysis, right? Water molecule, right? So upon hydrolysis, what will happen? This H, see beta, this oxygen is what? More electronegative. Magnesium is electropositive, right? This is H plus, this is OH minus ion. So what will happen? The opposite ion will get added to this molecule, right? Bond will break from here. So the opposite ion is nothing but this is H plus ion, right? So this molecule H plus will get added. And since this is positive, magnesium is partially positive and this OH ion, hydroxyl ion is negative. So hydroxyl ion will get added to this thing, this way. So this is obvious. Understood or not beta? This is obvious. Ethanoid. So we'll get, so you'll see if you have taken a compound like this, methyl magnesium bromide. So we'll get an acid which containing more than previous case, whatever product, like whatever raw material you have taken, right? Plus one. So if you have taken methyl, you will get ethyl. If you will take propyl, you will get butyl. Correct? Butanoic acid. Understood? Easy. Okay. So this was from the Grignard reagent, right? Understood? Now let us understand this with the alkenes. So let us take ethene. So this is our ethene molecule, है ना? अब ethene molecule में क्या होगा बेटा? Add this carbon monoxide. So what will happen? Carbon monoxide plus steam. This is steam. Carbon monoxide plus steam. So what will happen? In the presence of what? In the presence of which acid? In the presence of phosphoric acid. So this is phosphoric acid, H3PO4, phosphoric acid. So this is a very famous reaction. Let me just write the name of this reaction. This is Koch reaction. This is famous reaction, Koch reaction. So what happens? You will take ethene molecule. You can take any alkene, but that should be primary alkene, right? Take any ethene molecule, add carbon monoxide plus steam in the presence of phosphoric acid. So this is what? This is phosphoric acid. So what will happen? What will happen? There will be formation of this carbon monoxide will get added to this compound. Do you know how this thing will get added? Any idea?
Yes,
Can you like help me to understand the
mechanics?
mechanics? Okay, Markovnikov rule. Okay, so if you'll see how this is going to happen, this complete compound is going to add it to this compound. So you can also refer this is like whatever we'll get, that will be addition product. So we'll get compound like this. Understood? If you see, this is H2O is nothing but this is H plus OH minus ion. Correct? This can be written in this way.
Yes.
Understood? And this is what? This is carbon monoxide. So carbon monoxide look like what? So this oxygen will be what? Negative. This carbon will be partially positive. Understood? So if you combine all this, you will get this kind of molecule. So if you are taking ethene, then you will get what? Propanoic acid. So 1 carbon more than that you have taken, right? Propanoic acid. Understood? From the propanoic acid. Now let us understand this thing with the anhydride. So how you will get this thing from anhydride? So I guess like from anhydride, this is not important. So we'll not cover this because this is not much important, right? So let us understand the physical properties. This was all about the methods of preparation, right, Rita? Now let us understand the physical properties of carboxylic acid, right? So let us understand physical properties of carboxylic acid. So first we will start with solubility. Solubility in which medium? In water, beta. Solubility in water, not in other compound. We are discussing solubility in water. So these carboxylic acids are soluble in water or not soluble in water?
So they are soluble in water.
Why they are soluble in water?
Hydrogen bonding.
Like hydrogen bonding are of two types. There is intermolecular hydrogen bonding and there is one term which is known as intramolecular hydrogen bonding. So how they will form hydrogen bond and which type of hydrogen bond they will form and how they will become soluble in water. These are the questions.
Sir, intra-hydrogen bonding, I think.
So intra-hydrogen bonding means what? Hydrogen bond between same molecule or hydrogen bond between two different molecules?
Different molecules.
Correct. So they will form intramolecular hydrogen bonding. How they will form? If you will see the structure, they form hydrogen bond with water. How they will form? Let me just draw a structure very quickly. So this is what? This is your water molecule, correct? HOH.
Yes, sir.
So let's suppose this is your water molecule, correct, beta? Now this H is of the acid. This H belongs to acid, right? In this way. And if you'll if I'll draw the structure once again, you will come to know that this will look like this. So what is happening? This acid is forming what? Hydrogen bond with water. So that is why this acid is what? Soluble in water. Understood?
Yes, sir.
Got it?
Yes, sir.
So if you will see the complete structure, you will not be able to distinguish which is OH ion, which is H ion, and which is water molecule, which is the H and OH ion of this acid, right, beta? Right?
Yes, sir.
Right. So if you'll try to see, this structure is nothing but this is written like this: RCOOH. So I have rotated this thing. This thing I have rotated. No, I have rotated and I have put this structure here, right? So if I rotate this structure and I'll put here, you will get this is water molecule. This is are you able to understand or not, beta? So let me just draw this thing. This is my what? This is my carboxylic acid. See this. Only orientation is different. This is my carboxylic acid. Try to visualize this thing, beta. This thing is rotated, no? So that this OH comes on this side, and okay, let me just rearrange this, then you will understand. I'm writing this OH here, right? So OH, right? Or in this way, HO, correct? This was my carbon, so I'm writing carbon here. I'm placing this R as it is, right? And this is my double bond. So you see, this is nothing but this is my carboxylic acid only. So this is my what? This is my water molecule, and this is also my water molecule. How these two molecules got joined? How? Because of the electronegativity difference. See this oxygen here of the water molecule, this is electronegative, slightly electronegative. Partial negative charge will be there on this hydrogen atom. They will be partially positive charge. So you will get a dotted kind of this thing. So this dotted thing represent your hydrogen bond. Understood? Understood, beta? Here also you will see the electronegativity difference. So this is our hydrogen atom will be partially positive charge and oxygen will be partially negative. So in this way we get the intramolecular hydrogen bonding. So that is why when we will discuss about the solubility of this water molecule, so water molecule, this carboxylic acid is soluble in water, but only up to how this is soluble, only up to C5 carbon, only up to C5 molecule. These carboxylic acid are highly soluble in water, and once you increase the molecular mass, this becomes less soluble. Why on increasing molecular mass this become less soluble? Why? Yes, solubility decreases, because once the molecule gets heavy, your solubility decreases. Understood? The same example, right? Now let us understand the boiling point. So how you will understand the boiling point? Understand this boiling point, trend of boiling point. See beta, we are comparing this boiling point as compared to the parent alkane. If we are taking this compound as ethanoic acid, so we are comparing this boiling point of ethanoic acid with the parent alkane. Parent alkane will be what? Ethane. Correct? Correct? So we are comparing boiling point from this, like between these. So if you will see this structure of carboxylic acid, I am focusing only on this part. I am not focusing on the methyl group which is attached. I am only focusing on the functional group. So if I'll zoom here, what you will get? Let me just zoom and you will get a structure like this. Can you see a structure like this? So if you'll see, this oxygen is what? This oxygen is what? More electronegative than hydrogen, so this will pull shear pair of electron towards itself. Correct? Correct? Now what will happen? This oxygen will be what? More electronegative than this carbon. So what will do? This will also pull shear pair of electron of carbon towards its side. Correct or not?
Yes, sir.
Correct? So this has become what? Partially negative. Sorry, partially positive charge will be there. So what will do? What will this carbon will do? It will try. See, if this oxygen is pulling the electron of this hydrogen atom, so there will be partially what? Partially negative charge, and this will be partially positive charge. So if it has more electron and it has less electron, this carbon, so what carbon will try to do? It will try to pull these extra electrons towards itself, so that there will be this kind of effect. There will be plus I kind of effect in this compound, if you see. Understood beta or not understood?
Yes, sir.
So if you see this kind of bond in which there is a electronegativity difference, there is polarity, this kind of bond is nothing but this is known as intermolecular hydrogen bonding. Bonding between same molecule. Correct? Intermolecular hydrogen bonding. Correct?
Yes.
So there is a intermolecular hydrogen bonding is there. Why intermolecular hydrogen bonding is there? Because this is highly polarized molecule is present. Correct? Correct?
Yes.
Correct or not? So now tell me, if there is highly polarized molecule is there, intermolecular hydrogen bonding is there, right? So what will happen? Boiling point will increase or decrease? Now tell me, boiling point will increase or decrease? Will it increase or will it decrease? Intermolecular hydrogen bonding is also present. So if I tell you, let's see this molecule, this alcohols, and observe this group. Let me just erase this thing, alkyl group, just focus on this functional group, OH. So here you see there is also intermolecular hydrogen bonding in alcohols also. But what is special in this compound, this acids? Any idea? Intermolecular hydrogen bonding. Which is more soluble? This molecule is more, I'm not discussing about solubility. See beta, since you see this OH, there is also intermolecular hydrogen bonding. You see this OH, here is also intermolecular hydrogen bonding is present. But what is happening? What is the basic difference between these two functional groups? If you focus on this, you will see this oxygen and this hydrogen, they are highly polarized. That is great. What do you understand by highly polarized? Means the electronegativity difference is more. They are highly polarized. The strength of positive and negative charge is more as compared to this OH ion. Correct or not? Because of the presence of carbonyl group. Understand or not? So when I was discussing about solubility, when you focus, this OH, this COOH molecule, carboxylic acid, is more soluble. Why? Because it can form hydrogen bonding by two cases. How? First, it can involve the oxygen of carbonyl group, and second, it can involve the hydrogen of this OH group. Correct or not? In two ways it can form hydrogen bond. This is why this is more soluble than the alcohol and the parent alkane itself. Correct or not? Correct, beta? Have you understood the concept? Why this is more soluble?
Yes, sir.
So in a similar way, its boiling point will be more as compared to alcohol, as compared to the parent alkane. Why boiling point will be more? Because the strength of, see, stronger the strength will be polar charges, more stronger will be the hydrogen bond, and the more stronger will be this bond, there will be more energy required to break this bond. So if more energy is required to break the bond, then the boiling point of the molecule increases. Correct or not? Have you understood now?
Yes.
Understood? Understood. So this was all about the boiling point and the solubility. So this was about the solubility and boiling points. So let us understand one more concept. So you see these compounds, they form dimers. How they form dimers? Dimers is what? Dimerization is what? Dimerization, just like we have understood condensation in yesterday's class, in previous class, the same concept is solved with the dimerization. What happens in dimerization? Same molecule, they combine to form a new molecule, cyclic dimers. See, when I am discussing this hydrogen bonding, this is also important. See, you see this compound, this is what? This is our carboxylic acid. Correct or not, beta? This is carboxylic acid or not? Only orientation is different. This is carboxylic acid. So you see, if I'll bring another carboxylic acid, what will happen? This is H, this is O, this is C, this is O, this is R dash. Let's take this R as it is. So what will happen? This, between this oxygen and between this hydrogen, there will be hydrogen bonding. Correct or not? Correct? And between this hydrogen and this oxygen, there will be hydrogen bonding. So if there is a bond between two molecules, then what happens? These two molecules get dimerized to form a cyclic compound. So that is why they form cyclic dimers. Cyclic dimers. This carboxylic acid, what they do? They form cyclic dimers. Understood or not? So why they form cyclic dimers? Because of the hydrogen bonding from two sides. With this carbonyl group, oxygen of the carbonyl group and hydrogen of this OH. Because this is a highly polarized molecule. If you see this oxygen and hydrogen, this is highly polarized. Understood or not? Understood? They form cyclic dimers. Okay. Good. Now let us understand their melting points. Now let us understand the melting points of this carboxylic acid. So there are two cases. How there are two cases? Let me just tell you with a simple example. Let us take this compound in this way. A zigzag kind of compound. This. So how many carbon atoms are there? Can you count and tell me? How many carbon atoms are there, including the carbon of the functional group?
4.
Simple counting. Tell me. 1, 2, 3, 4. There are 4 carbon atoms. Four carbon atoms are there. So this 4 is an even number or odd number? This is an even number. Correct? So you see this CH3 and this group, these are known as terminal molecules. So this COH group, this is a terminal molecule, terminal side, and this is another terminal side. Just like you see in a metro station, no? There are two terminals. Right? So there are two terminals in this molecule, and this is an acid, carboxylic acid. So what you see special in this compound, if you see the structure, the terminals of the group are on the opposite side, right? They are on the opposite side.
Yes, sir.
So what will happen when they are opposite sides? So if we are taking odd number of even number of carbon atom, then they are on the opposite side. Let's take odd number of carbon atom and let's see what will happen. So if we take a compound like this, in this way, CH2, CH2, then what? Then what beta?
Carboxylic acid.
CH2, then COH. So if you'll see, these two terminal groups are on the same side.
Yes.
Right? Here, how many number of carbon atoms are there? 1, 2, 3, 4, 5. Total कितने हो गए बेटा? 5 carbon atoms are there. So 5 is an even number or odd number? This is an odd number. Correct? So what is the concept of even and odd here? Let's understand. So you see in the first structure, if we are taking even number of carbon atom, then we will get a zigzag kind of structure. Zigzag kind of structure. Right? So if we take a zigzag structure, then what will happen? There will be a formation of what will be happen? See, if you will see this molecule, if the molecule contains zigzag kind of structure, right? So these molecules get closely in the crystal lattice, and because of this, the packing will be more efficient, and this leads to the formation of strong intermolecular hydrogen bonding. In strong intermolecular forces of attraction will be there, and so if there are strong intermolecular forces of attraction are there, so melting point of this acid will increase, of which that they are containing even number of carbon atoms. Understood? See, this is a zigzag structure, no? So if the structure is zigzag structure, then during the formation of crystal lattice, this zigzag structure can easily fit into that crystal, and if they can easily fit, they can form more. There will be more intermolecular forces of attraction. So if the intermolecular forces of attraction will be more, so the melting point of this carbon atom containing even number of carbon atom, these molecules will have high melting point as compared to this carbon atoms compound containing odd number of carbon atoms. Understood or not? This will not fit into this crystal lattice completely. This will completely fit into this crystal lattice because of this zigzag shape. Understood? So this is very important concept. So this will have less melting point, less MP, and this will have high MP. high, this is high MP. Understood? Understood, beta?
Yes, sir.
Good. So now, let us understand the chemical properties of carboxylic acids. So what will happen in this? See, this chemical property of carboxylic acid depends upon two things. One, the reaction will be due to. So let us understand all the scenarios. So first possible scenario of the reaction is due to the hydrogen atom. Because of this hydrogen atom, first possibility, correct? The second possibility is complete OH group. What is the third possibility? This reaction can be due to whole carboxylic group, this acidic group. Correct?
Yeah.
And there are reactions which are due to this alkyl group. Understood?
Yes.
So these are the possible cases. We'll understand all these cases one by one. So first of all, let us understand the there is a famous constant which is known as dissociation constant. So what is the dissociation constant? Let's see. If you will take this carboxylic acid in this way, and if you will add a water molecule, what will happen? This carboxylic acid will get dissociated, beta, in this kind of ion. This is what, beta? This is carboxylate ion. Correct, beta? Carboxylate ion. And this ion is what, beta? Hydronium ion. So this is why this is known as acid. Why this is known as acid? Because it furnishes hydronium ion when it is dissolved in water. So any compound which furnishes hydronium ion, that compound is known as acid. Any compound which furnishes hydroxyl ion, OH ion, that compound is known as base. Correct or not? So this is why this carboxylic acid, this is known as acid, right? So now, how we come to know about the acidic strength? We will understand the acidity of this compound with the help of a constant which is known as dissociation constant. So let us understand what is dissociation constant. So dissociation constant is nothing but, this is ratio of concentration of this molecule, carboxylate ion, this carboxylate ion, divided by concentration of this hydronium ion divided by this acid multiplied by this water. So this is known as what? This is known as dissociation constant.
Yes.
We will understand this thing when we will study electrochemistry. So this bracket, you see, this is nothing but, this is product divided by this reactants divided by, sorry, this is what? This is my product, right? This is my product and these are reactants. So this is what? Product divided by reactants, right? So we will understand this when we will study electrochemistry, right? We will understand this K, kPa in a great detail there, right? So for now you can just see this is known as dissociation constant, right? So higher will be the value of K, higher will be the acidic strength, more will be acidity. More will be acidity. So if you will see a kind of table in which different values of K are there, right? So if I'll tell you the value of K for an acid is nothing but 17.7 into 10 to the power 5. This is acidic strength of methanoic acid, and acidic strength of 1.75 into 10 to the power 5. This is of what? This is methanoic acid, right? Understood? So can you tell me out of which by observing the value of K, which is more strong acid and which is less acidic?
Methanoic.
Methanoic acid is what? Stronger or weaker?
Stronger.
Correct. Methanoic acid is stronger acid as compared to the ethanoic acid. So now we will understand this concept. Since now we have understood the value of a dissociation constant, and there is another value, this is Ka. Ka is known as dissociation constant. But what is pKa? pKa is what? See beta, pKa is nothing but negative of logarithmic. We are taking this log which has base 10. This is known as pKa, right? So if the value of Ka is more, then the value of pKa will be less, correct or not? If this is more, then the value of pKa will be less, correct or not?
Yes, sir.
So there are two ways. If the value of Ka is more, then you say that acid is more stronger acid. But if the value of pKa is more,
Weak acid.
weak acid. So for stronger acid, the value of pKa should be less. So ultimately when you put this value Ka directly, you will get this pKa is less. So for pKa less, the acid will be stronger. For this also, for K more, your acid will be stronger. Understood or not?
Yeah.
This is simple, I guess. To start the chemical properties, right? So now let us see the resonating structure of this carboxylic group. So let me just draw resonating structure of carboxylate ion. So this carboxylate ion look like this. This is, what is the valency of oxygen? What is the valency of oxygen?
Valency. 7.
What is the valency of oxygen?
6.
Are you sure 6? Okay.
Yes, sir.
So now let's see what is happening in this resonating structure. You see this this oxygen is more electronegative than this carbon, correct or not? This oxygen is more electronegative than this carbon. So what will happen? This will pull this shared pair of electron towards itself, correct or not? Correct?
Yes, sir.
And you see, when this will happen, this electron will be shared here like this, correct? So when we draw the equivalent resonating structure, this will look like this. There will be negative charge, there will be a double bond. Here there is a loss of electrons, so partial positive charge will be there. This thing. So how this delocalization of electron is happening? What is happening?
The electrons are
See, if you see here, this OH group has which charge? This has positive charge, correct or not, in the resonating structure?
Yes, sir.
So if this has a positive charge, this OH group develops a positive charge, then it means that it has a tendency to attract the shared pair of electrons.
Yes, sir.
And what is happening to this oxygen of carboxylate ion?
So it has developed a negative charge.
So what is the ability of this?
So it will attract positive charge to the look there.
So what you have understood by this? What will happen now? This is my first structure, this is my second structure. Now what will happen? See, when there is a positive charge on this oxygen, then what this oxygen will do? This oxygen will ultimately try to get this electron, the shared pair of electron from the hydrogen itself. Correct or not? Correct? Correct? So now let us draw the structure. So what will happen? This was our oxygen having this kind of single bond and negative charge. So this is this thing in this way. Correct? Understood?
Yes.
And now if the oxygen here, which was positive, and it has taken the shared pair of electrons which was in between oxygen and hydrogen, then this will look like this. Correct or not? So this is third equivalent structure. Easy or difficult? Easy.
Yes, sir.
So what will happen now? This thing can go here and this thing can go here. So here you see like this. So this is fourth structure. So these are the complete structure of resonating structures of carboxylate ion. So my question is, they are resonance stabilized or not? Tell me. You see, this is what? This is carboxylate ion. This is carboxylate ion. This is also carboxylate ion. Correct? This is carboxylate ion. And this is what? This is acid. This is acid. This is also acid. So you see there is a acid and there is a carboxylate ion. So tell me, which is more resonance stabilized? Acid is more resonance stabilized or carboxylate ion is more resonance stabilized?
What does the resonating stabilize?
See beta, if you'll see the structure, the resonance stabilization of carboxylate ion is far greater than that of acid. Why? Because the carboxylate ion is much more stabilized by resonance as compared to the acid. Why this is happening? Let us discuss the factors. So if we'll see the structure 1 and structure 2. So let's see structure 1 and structure 2. Observe over here. Let's see structure 1 and structure 2. So if we'll see the contribution of structure 1 and 2 of this carboxylic acid, they are not equivalent and they are possessing different energy contents and different stability. Correct or not?
Yes.
On the other hand, if you see the structure, these other two structures, this structure 3 and structure 4, what you will see? The energy content, because since the carboxylate ion is same, so the energy content is also same. And if the energy content is same, they will be equally stable. Understood? So therefore, yes, the contribution of equivalent structures towards the stability of a molecule is greater than that of non-equivalent structures. This is why carboxylate ion is more stable as compared to the carboxylic acid molecule. Understood or not?
Yes.
These two structures are not equivalent. They have different energy content. Right? Structure 1 and structure 2.
Yes, sir.
And they have equivalent structure. So that is why carboxylate ion is much more stronger than the carboxylic acid. Right? And there is another way to understand this. What is the other way to understand this? So if you'll see this structure, observe this structure second. Try to observe this structure. If you see the carboxylic acid here, right? So this carboxylic acid possesses separation of opposite charges, that is positive and negative charge. Can you see?
Yes, sir.
And there is some energy is also involved in it, right? And if you see this structure second, focus on this structure second, this structure second only. So what is happening? In structure second, there is a high energy content as compared to that of structure 1. See structure 1, see. Why there is a high energy content and why here is energy content is less and here energy content is more? Why? Because this structure second contains separation of opposite charges. Here you see na, there is separation of opposite charges.
Yes.
So see beta, this molecule is a polar molecule. So there will be, when I am talking about energy separation, this thing, it means that I am discussing about this polarity thing. Correct or not? So if you see this structure, the energy difference, this is, the energy structure here is more and the energy content here is less. Understood?
Yeah.
And let's see the third one. See the third one and fourth one. Do they have any energy separation or like energy thing? Any extra energy in, like involved, or these two structures look very similar?
So they look very similar.
There is any charge difference?
No, sir.
No. Understood?
Yes, sir.
So that is why carboxylate ion is much more stable. So now I'll tell you what factors this acidic strength will depend on. Understand?
Yes.
So see, your acidic strength depends upon two things. First thing is ease of release of hydronium ion, H plus ion. Ease of release of hydronium ion, and anything, any group which will help to stabilize the carboxylate ion, that will also increase the acidic strength of this carboxylic acid. Correct or not? Ease of acidic, see the acidic strength of carboxylic acid, the very first common example is what? Any acid which has more ease to reach the hydronium ion when dissolved in water, correct? That compound will be more acidic. And the second factor is, it should, whatever functional group it attached to this COOH bond, COH functional group, that should stabilize the carboxylate ion. So if it will stabilize the carboxylate ion, the acidic strength of that carboxylic acid will be more. Correct or not? Anything which will destabilize the carboxylate ion, that will be less acidic. Understood or not? Understood?
Yes, sir.
Understood? So now we will understand why formic acid is more acidic as compared to the ethanoic acid, as we have seen the value of Ka itself, the value of dissociation constant. Understood?
Yes, sir.
So now let us understand the very first step, that is effect of electron releasing substituent. So let's understand this with two examples. Let us take formic acid. The structure of formic acid look like this. This is formic acid, and this is what beta? This is structure of ethanoic acid. Right? So
Yes.
we are discussing effect of electron releasing substituent. So what I've told you anything which will stabilize the carboxylate ion, that will be more stronger acetic acid, and anything which will destabilize the carboxylate ion, that will be less acidic. Correct? So what is happening? If you see this methyl group of this ethanoic acid or acetic acid, what this group is doing? This group is doing what? This is actually increasing the electron density at the oxygen of the OH group. Correct or not? See, this is my methyl group. Methyl groups are electron releasing group. No, they are not electron withdrawing group. These are electron releasing group. They are pumping electron to the system. So if they are pumping the electron, so this, it means that oxygen is more electronegative. So what will do? It will pull the shared pair of electron toward this side. It means that now this OH molecule has become less polar.
Yes, sir.
And therefore, the ease of release of this H plus ion is difficult now. Understood or not?
Yes, sir.
So if there is an electron releasing substituent which is attached to this carboxylic group, so what is happening? This is actually increasing the electron density and therefore decreasing the polarity of this compound. So if the polarity will decrease, the ease of H plus ion will be difficult. Understood or not?
Yes, sir. Understood.
Right. So if you see this structure in the acetic acid, this is an electron releasing group, right? And therefore if you see this arrow, this is nothing but this is plus I effect. Correct or not?
Yes, sir.
And plus I effect, what does plus I effect does? Plus I effect increases the electron density, right? This is increasing electron density, right? And therefore the release of H plus ion by the acetic acid will be more difficult. And also if you see this plus I effect exerted by this methyl group, this group increases the magnitude of negative charge present on the carboxylate ion as well. Therefore it is making the carboxylate ion less stable as compared to the carboxylate ion of this formic acid. How? Let us draw the structure and then we will understand. See, this is my carboxylate ion. I am drawing this dotted line. Right, beta? And there is a carboxylate group. I am drawing this dotted line. So what do you understand this dotted line? This dotted line represents that there was a double bond and then single bond, then double bond and single bond because of the resonating structure. There are two resonating structures of carboxylate ion. No, we have already discussed in previous topic. So now tell me, beta, this is your carboxylate ion. This is also carboxylate ion. This is also carboxylate ion. But the only difference is the functional group which is attached. So here if you see this methyl is what? Electron releasing group. Electron releasing group. So tell me, this methyl group, what it is doing? It is intensifying the negative charge present on the carboxylate ion. Correct or not? What will this do? This will pump the electron towards this carbon atom. Correct or not?
Yes.
So this structure already contains a negative charge on the oxygen atom.
Yes, sir.
So what it is doing? It is intensifying the negative charge on the carbon of the carboxylate ion. Right? So this structure, this electron releasing group is what this is doing? This is decreasing the stability of this carboxylate ion. So this carboxylate ion is less stable. Less stable. This is more stable. Because there is no electron releasing group which is attached. Beta, are you able to understand or not?
Yes, sir.
See, if I'll add anything which will pull all the electrons toward this side, so that will increase the stability of this carboxylate ion, correct or not?
Yes, sir.
Correct? Correct or not?
Yes, sir.
Correct? So this, if you see the carboxylate ion, this system already contains negative charge. So if you are adding more negative charge, this structure will become less stable. What it wants something which should pull the negative charge towards its side. What it wants minus I effect. But instead of minus I effect, you are giving plus I effect. It means that you are actually increasing the electron density here on the carbon atom. So this structure will become less stable. This is obvious or not? This is not very hi-fi rocket science. This is very simple. If you'll try to understand this. This is very simple. Understood? So if I'll write, now I can write this thing. Understood or not, beta? I can write the acidic strength in this order.
Yes, sir.
The order of acidic strength is correct or not? Correct. So this formic acid, this is strongest acid among all carboxylic acid. Now in theory, can you write the entire thing which I have told you? This is the order of acidic strength. Order of. Have you understood? Beta, have you understood? This is the order of acidic strength. Correct?
Yes, sir.
Good. So what will happen if there is an electron withdrawing group is placed to this? What will happen? Let's suppose this is what this methyl group, this is what this is electron pumping group, right? This is plus I effect. So this plus I effect, we have seen that this is destabilizing this carboxylate ion. So if we take a compound like this, chlorine, so what will happen? This will, what it will do? It will facilitate what?
Minus I effect.
Minus I effect. So minus I effect will do what? This will stabilize the carboxylate ion or not, beta? Tell me.
Sir, it will not stabilize the carboxylate.
Why it will not stabilize? This plus I effect, see, don't understand this randomly, try to understand this from basics. This methyl group is doing what? This is intensifying negative charge. See, why I am making this kind of curly bracket sign and I am writing this minus? It represents that this minus sign first come on this oxygen and then this oxygen. It means that this minus sign is delocalized on both the oxygen atoms, correct? So there is already minus charge on this group, functional group. And if you are adding a group which is intensifying the minus charge on the carbon atom, correct or not? So it is intensifying. So this is why you want something which can pull this extra charge toward this side, so that this will become stable, correct? So instead of this electron pumping group, I have placed electron withdrawing group. Chlorine is what? Chlorine is electron withdrawing group. Now what will happen? All the extra charges will flow in the structure in this way. Minus I effect. So minus I effect will stabilize the carboxylate ion or not?
sir, it will.
It is actually decreasing the charge density.
Yes.
So therefore stabilizing the carboxylate ion. So if it is stabilizing the carboxylate ion, more stable carboxylate ion will be what? More acid, more acidic or less acidic? I'm writing here. More stable the carboxylate ion, more will be acidic strength. Correct or not? Understood?
Yes, sir.
Dekho. See this. Now tell me which is tell me the order of this thing. Acidic strength. Tell me the order of acidic strength. See, the stronger will be the electron withdrawing group, the more stable will be this carboxylate ion. So fluorine, chlorine, bromine, iodine, out of which is the most electronegative and that will pull the shared pair of electron?
Fluorine.
Fluorine is the strongest of all. Correct? So what will do? This carboxylate ion will be more stable because this fluorine will be able to attract more negative charge from here, right? So the structure will try to stabilize. See, if the structure has this negative charge, beta, if the structure has something, this has a negative charge. So what happens? In nature, we always try to stabilize ourselves. This molecule also tries to move from higher energy content to a lower energy content. Only then this will become stabilized. Correct or not? So this fluorine will more stabilize this carboxylate ion. So this acid will be what? This will be more acidic. Correct or not? Correct, beta? So the order of acidic strength will be this. Strongest is strong acid. Strongest. This is weakest. Have you understood?
Yes, sir.
This is easy or difficult? Easy, beta? Easy or difficult? Easy?
Yes, sir.
Good. So now, beta, if I'll place any electron withdrawing group, let's place any electron withdrawing group. So what will happen? If I'll place any electron withdrawing group, what will happen?
Electron withdrawing.
Yes.
So the stability will increase and the acidic strength will increase.
Correct. Correct. Good. Now I'm drawing compound like this. I'm drawing some structure. Tell me the order of acidic strength. What should be the order of acidic strength? This is Cl. This is very important, beta, as far as the JEE mains and NDA exams are concerned, right? This is this can be asked in board also, but these questions generally come in your JEE mains and NDA. Correct? So based on your logic, based on your understanding, I'm drawing structures like these. So now tell me, this is one, this is second, this is third. Which will be, what should be the order of acidic strength?
The first will be the strongest.
And you have to support your answer by giving proper logic.
First will be the strongest because the chlorine atom is attached to the alpha carbon, so it will stabilize the carboxylate.
Correct. This is the correct logic. So this is the correct order. So why this is more stabilizing? Because this is my main functional group and this is alpha carbon. So if you see on the alpha carbon, we have this electron withdrawing group. So if the electron, so this acid will be stronger acid only when it will stabilize faster the carboxylate ion. So if it has to stabilize the carboxylate ion faster, it should be near the carboxylate ion. Correct? If you'll see here, this electron withdrawing group has moved far from this functional group. So this is why this will be less acidic than this, and this will be very less acidic because this like as compared to the functional group, the position of electron withdrawing group is placed far on the terminal side of this molecule. So this molecule will be less acidic, least acidic, and this is what? This is most acidic. So this is what? This is what order of acidic strength. Understood? Have you understood this?
Yes, sir.
Concepts are very easy. Very easy concepts are there. So in this way we can understand well all these things, right?
Yes.
So if there are different structures will be there. So if I'll give you a compound like this, let's I'm giving a compound like this. This is what beta? This is chlorine. This is my carbon. This is chlorine. This is chlorine. This is COH. Right? This is very important question beta as far as this J mains are concerned. Anj, very. Right beta?
I think maybe left.
Okay, no worries. No worries. ठीक है? सबका अपना अपना स्ट्रेंथ होता है बेटा, सबका हर बच्चे का अपना अपना स्ट्रेंथ होता है. तो ऐसा नहीं है कि कोई बच्चा अगर किसी के अंदर कम स्ट्रेंथ है तो वो कमजोर है, ऐसा नहीं होता. सबका अपना अपना स्ट्रेंथ है. कोई बच्चा किसी चीज में स्ट्रांग होता है, कोई बच्चा किसी चीज में स्ट्रांग होता है. सो अल्टीमेट थिंग इज योर लाइफ, है ना, कि आप लाइफ है आपकी, आप उसे कैसे कर रहे हो, कैसे सारी चीजें मैनेज कर रहे हो. दिस इज द वेरी इंपॉर्टेंट. ये है ना सारी चीजें. इफ यू आर सुपीरियर इन स्टडीज, इट डज नॉट मीन कि यू आर सुपीरियर इन योर लाइफ एज वेल. आई सी सम पीपल who are not superior in studies but they are more superior in life. They are enjoying their life, not by indulging in good habits, but they are using their minds in different ways and very innovative ways. Correct beta? And you have seen very examples in past days, right? In past history you have seen many examples. Correct? So what you are expecting me to draw? You are expecting me to draw one more Cl here and then COH. So now can you tell me what should be the order of acidic strength?
Acidic strength.
Correct. This is very, yes, logically.
The trichloro compound and
This is trichloro compound. This is what beta? Meth. This is trichloroethanoic acid.
yes, sir.
Give it as name, no? Trichloroethanoic acid. Similarly, you can name this as dichloroethanoic acid. Please pardon me if I am writing wrong spellings beta, because I am writing in a hurried manner. So please pardon me for this. This is what? This is simply
Chloroethanoic acid.
monochloroethanoic acid, है ना? So tell me the correct order of acidic strength. See,
So tri then di.
and what is the correct logic behind this?
So because the fluorine atom has a strong electron.
See beta. What the like simple concept is, you see there are 3 electron withdrawing groups. 3 chlorines are there, it means that there are 3 electron withdrawing groups. So if there are more number of electron withdrawing groups, so this will try to do what? This will try to more stabilize the carboxylate ion of this carboxylic group. Correct? Here the ease of stabilization of this carboxylate ion will be higher as compared to this one, and then as compared to this one. More is the number of electron withdrawing groups, more is the ease of stability. More is the ease of acidic strength. So this will furnish this H plus ion in the water more easily as compared to this one and this one, more rapidly. So this is why this is most acidic, and this is better, this is least acidic.
Yes, sir.
Easy, very easy.
Yes.
Understood? This is the order of acidic strength. Right?
Yes.
Have you understood? Good. So we will stop here and we will continue resting in the next class.